Hello, everyone, and thank you so much for joining another episode of the Disruptive Front. Today, we have a very special guest, Dr. Daniel Kraft. Doc, thank you so much for joining me today.
Great to be with you, Scott.
Well, I want to let everybody know who you are because I've been following you since 2013. I was looking somebody up for innovation and disruption, and there your TED Talk was, and it blew my mind. I want to talk a little bit about you and all the innovations, disruption, and everything going on in the world. But first, let me introduce you to the world. Doc, you have been the chair of, or you are the chair of XPrize Pandemic Alliance Task Force, and we'll get into that a little later. You have been the chair for Singularity University, and last year, and hopefully this year, we get to see you as the chair for Exponential Medicine. You were the founder of Exponential Medicine, which we'll also talk about because I want to let the world know about that. And, you know, your years of experience and as well, one of the highlights, I think, is being a surgeon and a pilot as well. So I want the world to know who you are again, and really happy to have you on the show today.
Thanks for having me. Let's rock it.
All righty. Well, without further ado, I want to jump right into some of these questions. So some of the things that really stick out and you talk a lot about, I mean, I've seen you on stage walking back and forth and pulling things out of your pockets of your suit jackets and your shirt and your pants and so on. Wearables and digital therapeutics, the digital devices and things that we're using really to change the world. I mean, we see right now with cancer, mental health, there's, even you talked about it back in 2014 about artificial tattoos, and now you see Genetech and ink real world data and so on, and blood pressure cuffs and so on. What are we seeing in the world of wearables and diagnostics, and where are we moving into, and how do we capture data that truly makes a difference?
Yeah, it's not just about wearables, but we've got insidables, underwearables, digital tattoos, insidables. The main point is now we have the ability to start to collect our digital exhaust, our physiome, our digitome in lots of different ways, from your wrist. I'm wearing like 4 different devices, all the way to sensors that can be obviously just the ones on your phone, or some are embedded into implants or pacemakers or brain computer interfaces. The bottom line is it doesn't matter what the interface is. It's the point that now we're in an age which is relatively new, where we can start to collect our digital exhaust and measure almost every element of physiology and behavior. And to put it into perspective, it's only been 11 years, 2009, that the first Fitbit launched. And now, these are exploded everywhere. I just got basically a $10 wearable, the equivalent of an Apple Watch made in China, that can do, heart rate, calculates blood pressure, I'm not sure how accurately, oxygen saturation, and tells the time. And the problem and the opportunity is now we have all this digital exhaust, is how to make sense of it in the context of hopefully someone healthy, to see and optimize health, all the way to picking up signs of disease early, like changes in resting heart rate or heart rate variability or blood pressure or blood sugar that can soon come off of our wristwatch, and to put that in context of the individual and use that to optimize wellness, pick up disease early if it's there, or if you have a disease, everything from cancer to diabetes, to leverage that in real ways that are really actionable and useful. So it's not just about the gadget, it's about how you make sense of the data and use it in context.
And you've talked a lot about how some of these devices, they're basically, in today's world, they're not really connected. Well, maybe today because of what's going on, but they weren't really connected into the EHRs and accessible to providers at all beings. And, the data, there's tons of data that was maybe unnecessary for a hematologist versus an endocrinologist. Are we seeing that come together? Are we seeing those EHRs and those companies really make a complex setting where we can actually grab the data we need?
It's starting to be possible, but it's not completely leveraged yet. So today, we a lot of us, like you and I, are data geeks. We do quantified self. The data from our Fitbit or Apple Watch lives in our smartphone and maybe an Apple Health Kit. And now there's one for Android as well that can connect to medical records. Like my Fitbit data can go to Stanford, and my doc can see my steps and my resting heart rate, but he's not usually looking at that or doesn't know how to make sense of that in context. So the trick is to go from quantified self to quantified health, where we're enabling that information to flow, whether it's something important like blood pressure or blood sugars, not just the raw data, but that turn that into actionable information in context with each patient. And that could be leveraged by the cardiologist, by the pharmacist, by the social worker, hopefully by the engaged human, patient, consumer, so that we can use that to be much more proactive instead of reactive. Because as I've mentioned in the past, we practice more sick care, reactive based on intermittent data that we usually only get in the clinic or the intensive care unit. And we can take a lot of this new information and be much more continual, continuous, personalized, proactive, and start to do that anytime, anywhere, arguably at much lower cost with better benefit. But there is the challenge of how do you engage that, whether, again, with the doc, the nurse, the pharmacist, to make sure they can look at not just the data, but get the information, and then are rewarded, incentivized for using that. They can bill for prescribing the connected blood pressure cuff, or tracking your mental health using your typing on your smartphone. So there's a lot of alignments that need to happen. And because there's so many different healthcare systems in the US, let alone the world, we have to play with the sort of models to plug these in smart ways.
Well, I see a lot of jobs even being created during this time, during this pandemic. And it's, I think it's fast forward everything. I think it makes you and I both happier that people are actually using things. That's probably the only silver lining in that regard. And people are talking that never talked before. We saw this with the opioid epidemic when we were having everybody at the same table, which never happened before. Switching a little here and kind of sticking with the diagnosis side, things like CRISPR. And just so everybody knows out there, CRISPR allows you to manipulate the DNA and hopefully to reduce some of the sicknesses or predispositions in that regard. Can you talk a little bit about that? Because I think there is some skeptics, and we saw Theranos, for instance, out of California, and have that big, huge disruptive, using small blood samples to, create big data, and it really didn't go as planned, let's say. So can you talk a little bit about the CRISPR and where you think that's going?
Well, first of all, Theranos is pure. They're trying to do diagnostics on a drop of blood, and they had definitely some malfeasance and were claiming things that weren't possible. That whole field, though, by the way, of taking small amounts of blood and being able to analyze it on your smartphone or in a lab is definitely accelerating. But we need smart ethics and real business models moving forward. CRISPR is a bit differently, even though CRISPR can be used for diagnostics, as it is now in the face of our pandemic. CRISPR is only an 8 or 9 year old technology that enables very targeting swapping out of genes, which potentially can be used to cure diseases like single gene diseases like sickle cell disease or thalassemia, where in early trials it's looking quite promising. You take out the bone marrow from a sickle cell patient, replace out the bad hemoglobin gene, and reboot themselves with their own modified stem cells, and they're essentially cured of sickle cell disease. That's one promising area. In something as common as high cholesterol, there's some forms that are familial, and there's a company out of Harvard that's now in animal models and primates able to do gene therapy inside the baboon. It targets their liver, swaps out the gene or turns off the gene that was making high cholesterol. And that's another approach. And then all the way to the extreme of CRISPR babies, which happened unethically in China a year or so ago, changing in the in vitro fertilization side, not just eye color, but maybe looking at intelligence, not just knocking out genes, but trying to change this. There's a big, if you haven't watched the movie Gattaca, which is a 22-year-old movie, it really presages this incredible challenge, both ethically, regulatory, of how do we take the power of some of these exponential technologies, including CRISPR and gene engineering, which are going to completely rechange how we do reproduction and how we manage and treat and prevent diseases. So it's an exciting area with a huge spectrum. And it's even being used, CRISPR now, to potentially do very rapid point of care diagnostics, because you can use the CRISPR agent to determine if there's a particular virus and use your smartphone and a small lab on a chip to get that data at the point of care.
Well, and I know something at Exponential Medicine that was talked to a lot about was, and it's talked a lot about, you talk about it all the time, which is securing that data, and 23andMe's and the other companies that are doing these genome and I won't say full genome, right? But we see a lot of the data being sold off with Ancestry or so on. It's already hard buy-in, right? I worked in point of care testing, and getting people to do genetics, first of all, it was hard. It was a sell. I had to sell them on the idea of why they needed this, why it was the most amazing thing. How do we get more buy-in, and where do we see that data being secured in today's market?
Yeah, it's not just about, again, data. You can have exponential amounts of data from your wearables, from your genome, from your microbiome, from your sociome. And the challenge with buy-in is, well, so what? Just because you can have your whole genome on a disk, or your doctor has it, or your pharmacist, so what? I think there's some low-hanging fruit, particularly in the biopharma world, of using pharmacogenetics to pick the right drug and the right dose instead of one size fits all, which often means there's a lot of challenges with side effects and off-target effects and drugs that don't often work in a majority of the patients are prescribed to. I think what happens in the privacy side, we don't want our full genomes necessarily out there, because there's a lot of information about your risk for diabetes, cancer, Alzheimer's. Might that cause discrimination, whether from the workplace or insurance? But I think if we can start to secure that data, and there's technologies like blockchain that can help that. And if you think of yourself as a data donor, donating your omics, your medical records, and you get that information back in a useful way, you know, the Daniel or the Scott map of data informs the larger map. So when we want to optimize our health journeys, or those of our neighbors or friends or patients like us, it can all contribute. Kind of like I always call it the Google Maps or the Waze model, where we're already sharing our private data, our speed and location. Google knows where we're going. And from that, we build a real-time map showing, you know, the best routes, the timing to avoid the traffic jams or the speed traps. So I think it's about it being, when you're donating data in hopefully a smart, anonymized way, you get something back. And I think that's part of the future of health and medicine, because so much of our data is siloed. There's so much potential things learned in other places that we're not quite crowdsourcing enough to make useful faster.
Well, you know, you were talking about your app the other day, and you compare, well, an app that you compare to Waze in some sense. And I actually wanted to speak to you because I was talking to you about this the other day, that I wish when we were driving that, you know, this app would pop across and tell us the direction we were going, so we don't have to constantly look down at the phone, or tell us that, you know, how far the next gas station was or what's coming up to eat. So we're not constantly looking around. I want to get into the VR and AR setting a little bit. I've talked to Dr. Raphael Grossman, and I've always said to him, it's so terrible that we have to wait for somebody to get to his residency or his, you know, rotation in order for them to learn about this. And I feel education is missing a lot in there, but we're seeing so many disruptive companies come into play. You know, we have so many things from, you know, just being able to play a game to really treating things like pain and autism. And I wanted to hear what your thoughts are in the world, and what's taking consumers so long to adapt, and what's taking providers so long to adapt as well.
So I'll have to look that up on a second. Okay, got my answer. Thank you. These are my antique Google Glass. You know, this is an example. I mean, this is 6-year-old technology. It was pretty incredible back then. It still actually is. Of augmented reality trying to be consumerized, which wasn't a big hit, at least so far. But these, as Raphael and others have pioneered, are being quite useful in the field of medicine, whether you're in any kind of clinician, where you can pull up data. It's being used to scribe, so clinicians aren't having to type all their notes. But it's an example of, you know, all these exponential technologies coming together, where you can put a supercomputer basically in a set of glasses. And rumored is Apple to be coming out pretty soon with some sort of augmented reality glasses that will replace our iPhones. I think the potential is to realize how quickly these things are moving. I've got my Oculus Quest sitting there over on the shelf. I've done 100 days straight of exercise inside of a platform called Supernatural. There's all sorts of educational things for learning anatomy, gaming things for physical therapy. Folks in the biopharma space can look at molecules and help it for drug discovery and understanding mechanism. There's so much potential there to synthesize complex data for a surgeon who's operating to see through the patient and go step by step, kind of like a Waze for surgeons, all the way for consumers, patients, all of us to sort of see our world in new ways and potentially be nudged to smarter behaviors, not to have to wear a device on our face all the time, but ways to understand our own physiology or medical issues. And that can create engagement and better adherence if you're taking a statin or any other therapy. But it's a pretty incredible area of AR, augmented reality, virtual reality, and then XR, extended reality, where we're going to start to see these sort of cues embedded in our environments in all sorts of ways. And again, many, many applications, from how you train a surgeon to how you engage everybody to understand their health, their physiology, and to tweak that in smart ways that are personalized to them.
Well, I'm really happy to see a lot of the entertainers and, you know, different people that people know get into these spaces, because I think that's important for consumers to buy in. They have to feel like it's familiar, you know, hear the song that they like or whatever the case may be. So I think we're moving in that direction. Let me ask you, how do we bridge the gap between education and really what our potential is? Because one of the things with, for instance, VR is being in a place that you've never been before and feeling comfortable in that place. And then once you get there, you know it back and forth for the most part, depending on the amount of time and experience. So how do we bridge that gap? And how important is cross-fertilization, like you've had at Stanford, as an example for learning?
Yeah, I think we all learn a bit differently. You know, just like there's personalized medicine, personalized learning. You might be more visual, some is more auditory, some is more tactile. We all have combinations of those. And part of the power of, you know, virtual learning and flipped classrooms and AR and AI is that we can hopefully have a very tailored educational approach. But, you know, VR, as one example, is massive potential for education. you and I both probably learned, cardiac physiology, looking at images of a heart. Now you can walk into a heart and change its physiology out of, aortic stenosis or myocardial infarction, or look at the effect of a drug or a stent and see that in real time and hold that heart or walk inside it. Or it could be your heart if you're the patient, showing what's happening with the clots in your coronary arteries. And that might really instigate you to get on top of your statins or other interventions. So I think we bridged the gap by making the technology, number one, easy and seamless. And Oculus and others are making it pretty easy now to just put on the headset, and it's like using your remote control and be in all sorts of environments, from learning anatomy to playing engaging video games for health or for just for fun, or being social, because health is social and many other elements. And in our quarantine at home type model as we speak now, VR can be a platform for that. It can also bring classmates together to have discussion elements beyond the sort of Zoom platform. So I think it's about lowering the friction, obviously lowering the price, which is getting cheap. You can put your smartphone in Google Cardboard and have a VR experience. Our friend Shafi Ahmed pioneered that was in London 4 years ago in the operating room. He did the first live stream VR surgery. 5,000 medical students were watching that in real time on their smartphones in a Google Cardboard. So lots of opportunity, and doesn't need celebrity endorsement. It takes folks trying it out and getting it engaging and seeing that they can be on a mountaintop in the Himalayas or inside their own bodies or in an engaging environment around a campfire with their friends and family virtually. That is going to keep shifting the equation.
Well, you've been a pioneer in many ways. And one of the things that you've recently created was a pilot or a prototype of a 3D printing for a polypill. So can you talk a little bit about that? And then I want to get into the regulatory barriers that we're facing with a lot of these disruptive innovations.
So I think in a nutshell, we all see challenges in health and medicine as a physician, as a pharmacist, a nurse, social worker, whomever. And, one of the things I noticed being trained in pediatrics and internal medicine is that in kids, we, pretty carefully dose medications based on weight. When you're adult, everyone gets the same dose of Lipitor or Vicodin. And also we know that there's an issue with polypharmacy and folks taking piles of pills, especially as they get older, and challenges with dose adjustments, still using pill cutters. So I was thinking about this challenge and thinking about what if we could, using now our convergence of sort of 3D printing, 3D print essentially a personalized Polypill, a Scott pill, a Daniel pill that, starting with generics, would give you the ability to combine, let's say, your blood pressure medicines, your aspirin, your statin, your beta blocker, your Synthroid, your vitamin D, common generics, the right doses and combinations that might match you and your pharmacogenomics and your weight and your renal function, and to sort of 3D print that in a sense by sorting little, called the micromeds, into a capsule. So we prototyped that. We've got a version of a sort of desktop version for pharmacy and a small one for home. And the idea, again, is that we'll start to be able to take this to a point where we can print your combination in telemed and telemedicine tablet that could be modified even every day or every morning and every evening based on your blood pressure, your mood, your blood levels, so that we can truly move to an era of precision, personalized, updatable medication instead of waiting weeks or months to adjust blood pressure medicine based on a single value. Our digital health exhaust can start to inform, through AI machine learning, optimized drug combinations and dosings when drugs are needed. I think we should still focus on prevention, but in the case when you do need therapy, or you might think about a longevity polypill that's personalized to you that might have a little bit of, things that we know help, vitamin D, maybe your fish oil, but also might have things like metformin in it or rapamycin or other drugs that may play a role in slowing the biologic clock for some folks.
And what about the regulatory side? What barriers did you face? Because I know with all this innovation, it's trying to convince basically legislators, at a limited level of understanding for the biology and so on of what and technology, and really convincing them to say yes. I mean, we've seen it even in our state in Florida that it's really, really hard to say why we need something, even though it sounds magical and amazing, and it could be, but it's very hard to help them understand. So what are some of the barriers you face, and how important is it to really ensure that our medical providers or innovators are also understanding the policy side or teaming up with those individuals?
Yeah, we need to be partners with the regulatory world. As we move into this exponential age, a lot of our laws and regulations, which are well-meaning, are still from the analog era. They're not in the digital era. Take HIPAA, my favorite thing to bash on. I mean, it's supposed to be for healthcare portability. It's actually now been a hammer to prevent folks from sharing medical information when they might want to. The patient died with their privacy intact. They might have preferred to be alive with something shared in more seamless ways. Similarly, on the regulatory side, the FDA is basing their rules on things that have been written maybe 20, 30 years ago. And so now we have software as a medical device, and the FDA and their digital health team has been quite forward acting about thinking about how do you regulate an app or a medical device that has software built inside of it, like a pacemaker? So we need to bring the regulators along to see what's here and what's coming. So it's not always about convincing them. Sometimes they have to go by the regs. We need to update the regulations in some settings. In the setting of printing a personalized polypill, in some states that may fit under automated compounding, in some states it may not. So we have often state variants. So it's about seeing where the puck is going, bringing the regulators along, still focusing on, safe and effective therapeutics, not doing CRISPR modification of babies in IVF clinics, whether it's in the Bermuda, Bahamas or China, offshore.
Or unethical blood testing and stuff like that.
Well, blood testing may not hurt you, but when you're saying, oh, we're giving you a stem cell therapy, and it's not even a real stem cell or one that isn't managed in a safe and effective way, there's a fair amount of snake oil out there for eons. And it's not new, particularly in our connected age. Take this, it'll make you live forever. Or so there's a challenge in validating things, even in the setting of our current pandemic. A lot of misinformation. It's not just a pandemic, it's an infodemic about what drugs may or may not work, often based on anecdotes, et cetera. So we need smart science. We can catalyze science in clinical trials. Now in our age of doing connected mobile digital trials, you can download from Apple Health Kit dozens of trials for everything from Parkinson's to cancer to picking up the flu on your smartwatch-based data. So tons of potential. We need to bring everybody along.
Well, I want to fire some things at you real quick. So talk to me a little bit about digital.health and who needs it.
So the challenge in this age now is we have a lot of new digital health tools, whether it's wearables, apps, platforms like Omada Health for diabetes or others for managing mental health. And as a clinician, doctor, nurse, pharmacist, occupational therapist, nutritionist, there's a lot of these elements out there like the EKG on your watch, or an app to help with smoking cessation, or a wearable to help track your exposure to the sun, which might be relevant for certain folks, certain patients. And so I built early version so far of digital.health, that's the website, to be a bit of a digital health formulary. If you're trying to find apps, devices, solutions for managing cardiovascular disease, you can find that, or diabetes, or VR platforms that can be used in physical therapy. So the idea is that you'd come in as a clinician, be able to find the tools that match a patient, let's say, and be able to sort of prescribe those services, apps, devices, wearables, etc. Maybe it's sending them the link to download the app, or having the connected blood pressure cuff or glucometer arrive at their home and then have the data flow back into that clinician's workflow. So it's useful, and hopefully eventually have the insurance companies, the payers, cover smart digital health tools. So it's trying to see what's useful. Precision digital health, I think, is sort of the mission.
And talk to me a little bit about the idea of somebody getting into technology or innovation themselves. I mean, somebody has a great idea. They have even a prototype. What is the stages for them? I mean, I think of it so many times, and I talked to you about this before, is that you have a bunch of pharmacy students or a bunch of medical students, and they're like, we have a great idea, but they're not teaming up with the technician or the app creator or whoever. Where do they go? What's the funding look like? How do they get involved? Like, where's the first steps that you would recommend?
I mean, the first step, particularly when you're in a student mode, you see things with sort of beginner's mind. You see things like, why the hell are we still prescribing pills and pill bottles with these cases that, you'll see a challenge like, why are we managing hypertension with, checking a number once or twice a month and trying to tweak things. So you see things with, why the hell are we still using fax machines? You see a problem area. And then you can think, well, how might I be able to solve that? And maybe you come up with a good idea, the connected pill bottle or the 3D printed pill. Hopefully you can validate that idea, not just in your own mind, but talk to patients, caregivers, pharma, the payer, looking at it from the whole big perspective, and then try and solve that potentially with tools that you might have today, maybe a prototype with a 3D printer, or you could build the app, and then think about, this convergence. How do you bring other folks in? You may not know how to build the app, or don't have an engineer, don't know the basic engineering on 3D printing. You can do it yourself or find others. You can start to collaborate in new ways, in person or virtually, to solve that, not just with the technology today, but what's coming. We know with Moore's Law, have some predictions about what the next version of our smartphones or smartwatches can do. We are now in the era of 5G. We might plan for building for 5 or 6G. You can think about the power of artificial intelligence and what you can do now with a simple, TensorFlow element to build an AI platform that used to require millions of dollars of PhDs in labs can now be done in your college dorm. So tons of potential. Start with the unmet need, really validating that, and then start to build ideally an early minimal viable product, see that it has some traction with potential customers, and then and go from there. So many ways to go, but it starts with the unmet need and coming up with a solution that really matches that, not just for 2020, but for 2025 and 2030.
And my next question to you, and this is without any inside traders, I want to know, what do you think the next biggest thing in healthcare, digital devices, wearables, diagnostics, whatever it may be, what do you think personally that the next biggest thing in healthcare will be?
Well, I think I got to write the opening article for this Nat Geo in January of 2019 about the future of medicine, and they retained the title about 9 innovations that are changing healthcare. It's not about any one innovation in AI, robotics, 3D printing, nanotech, genomics, VR. It's how you put them together. And I think the big picture of the next big thing is connecting the dots between your behavioral elements picked up by your wearables, the insidables, the ambient technologies that can pick up behaviors and then help nudge those, whether it's the VR or your simple watch or AI. The fact that you'll have a bit of an AI coach that surrounds you, looks at you in context and builds a bit of a digital twin that you or your clinician or your healthcare system can use to optimize prevention, screening, do smarter early diagnostics, and if you have a disease, to manage it in a much more feedback loop iterated way. So I think it's the convergence of points, not any one thing. Clearly AI, machine learning, and the ability to now take all this massive data and turn it into actionable information, I think is really going to shift healthcare in so many ways, because so much of what we do is based on anecdotal experience or limited clinical trials. Now we have the ability to build a real world map of what works for certain individuals for certain elements. And I've used the Waze analogy before, and actually about a year ago, I met one of the early founders of Waze. They're now actually building a Waze for healthcare. It's called Stuff That Works, stuffthatworks.health. And you can now donate your data, learn from others like you, and hopefully build that better map. And I think that's part of where healthcare is going to go. AI, machine learning, using crowdsourced data to bring us much more personalized precision health, wellness, and therapy.
And, I want to talk to you about XPrize. And I think it's phenomenal. I want more people to be involved with it. So I want to, finish off with that. Can you explain to everybody what XPrize is and how to be involved with it?
Well, XPrize has been around for 15 or so years, starting with audacious prizes to address challenges. The first one was the Ansari XPrize to get a rocket to space that was not built by NASA. That was won like 15 years ago, and that's helped catalyze the new space age with companies like SpaceX, which are doing quite well. So the trick is to, and Lindbergh crossed the Atlantic to win a prize, as an example, and that opened up transatlantic travel. So X Prizes are often that same modality, challenging folks to get something done faster and better, a challenging, audacious goal. So for example, we just launched an X Prize for rapid, cheap, fast and easy diagnostics in the setting of our current pandemic, so that it doesn't take days, doesn't take lots of dollars. So that X Prize is out there at xprize.org/testing. And there are other prizes around retooling for learning, for creating avatars. So it's a bit of an engine for incentivizing with dollars and other ways, things to get out there faster. So check out xprize.org. There's lots of great elements where anyone can help join a team, form a team to try and tackle several audacious goals, including in longevity, in work, in AI, in healthcare, lots of potential there.
Well, Doc, where can everybody find you? I know you're on Instagram, Twitter, and so on. Just where can people find you so that they can start following this amazing content?
Sort of an overview is at danielkraftmd.net. And then I would encourage folks to look at Exponential Medicine. That's a program I chaired and have run for the last 9-10 years, which you came to last year. And Exponential Medicine, exponentialmedicine.com, is sort of all about seeing what's on the cutting edge and what's coming next. How do we collaborate better across the whole spectrum of healthcare? Last few programs in person, we've had 44 countries represented, 600 people coming together. A lot of the great talks are at exponentialmedicine.com/videos. And we'll have hopefully a virtual version of that this year, while we're still in our limited ability to meet in person. So those are the places I would go. And I'm on Twitter at Daniel_Kraft, and try and share out things that relate to the cutting edge and in the future.
Well, I want everybody to know Exponential Medicine was the best conference I've ever been to. I mean, I was sitting next to healthcare providers from around the world and just learning so much. I was with venture capitalists and innovators. I mean, I took a selfie with the guy that invented the mobile phone. I mean, it was the best time of my entire career, first of all. But it was just it was emotion creating as well. You know, there was a lot going on, and I think that's the biggest thing that you do is you create emotion. You know, even from your presenting to just your means of communication, you do create a lot of emotion. And I think that's what really is a trait of yours, and I appreciate that, and I appreciate you coming on the show today. I want everybody to know, you know, who you are, what you're doing, and I really appreciated that you accepted this offer to come on the show, this Disruptive Front. So thank you so much for your time today.
Well, thanks for what you're doing. It's not just about emotion, it's about passion and energy and getting people excited about all the amazing things that are here, things that are coming, and to challenge them to take all our crazy exponential tools and to reshape those in whatever form to make a better future for health and medicine and beyond. And for each of us now to become, you know, early, you don't need to be a proselyte or a crazy technologist to start trying some of these devices and solutions for yourself, for your patients, with your classmates. So there's that line, you know, the future's already here. It's just not evenly distributed. So it's up to all of us to start more evenly distributing it and hopefully catalyzing that future to help everybody moving forward.
That honestly means a lot. And I know you will keep the fire burning. You're definitely energizing people like myself and others. So thank you so much for coming on today. Everybody, this is another awesome show of the Disruptive Front. And I hope you guys keep watching. Tune in. We'll be on Spotify, iTunes, and of course, LinkedIn, YouTube, and so on. We'll disperse this information, but I really do appreciate it, Doc. I hope you have a great day. Everyone, I hope you have a great day. Thank you all for joining.